the Singleton pattern ensures that a class has only one instance. Regardless of how many times we initiate an object from our class, we will always get back the exact same one and only object. Now, why in the world would we want to do this? Well, there are situations when we actually want the single source of truth for some information in our application. Say we have a configuration object containing some maybe layout information. We want to make sure that this object is exactly the same object regardless of which component we are using and creating it from. If each component makes a new object, we will get, well, multiple copies. That is not what we want. What we want is one and only one configuration object in our entire application. In this module, I will show you one way of ensuring that this is the case, and in this skill builder module, you can open the source code and build one yourself to really understand how this works under the hood. Singleton provides us with this functionality, at least to a certain degree in JavaScript, because JavaScript is a loose language, but it is very useful in managing access to shared resources. Besides configuration, some users are caching, authentication, centralized data stores, error handlers, log services, file operations, routers in frameworks, etc. Any place where there is, by design, only one surface of its kind and only singular data in our application. That can happen quite a lot. So some of the advantages are consistency. Singleton ensures a single source of truth, reducing bugs related to duplicated instances. It's efficient because it efficiently manages resources by preventing unnecessary duplication. It has centralized access. It provides a single point to access shared resources by simplifying the code and actually improving readability. But it has some disadvantages. If overused, it can lead to hidden dependencies between objects and make, for example, testing more challenging. Could lead to a difficult debugging as well, because object could be changed or adjusted in some place in our application, not actually where we're looking at the code. So we basically have to check every possible use of the singleton in the code to make sure that nothing is changing the object along the way in our application. So singleton makes sure that we can only use one instance of an object and to always get the exact same object from the same class. And let's see how this works in practice. Let's look at one practical problem that Singleton solves, the one from the introduction. Here we have a configuration object where a user can set some configuration. In this case, the user can change the color theme in our application, so it could be light or dark. And we expect that if we change the theme color once in one place in our application, it will be consistently throughout our application, right? So that each and every screen, has the same color. So our problem is that we want a single source of truth if this is proper configuration, right? Regardless of which component or which controller we are calling this configuration from. So in practice, we only want one possible config object in the entire application. We don't want more than one instance of this object in memory and having to track ourselves which object are we actually using in this particular code. So that's what we call the single source of truth, only place where there is some information that we are working with. So here in the code, we have one object called config. Then in component number 1, we are calling this getSetting the theme. So this is just a variable, nothing special about it. So we're just retrieving this setting array or this hash map with the theme and maybe language someplace. I just have this example here. In the second component, a user could click on the dark theme icon and change this theme from light to dark. This one will output light. The second component will then change the theme to dark and it will output dark. However, the first component will still get a light. And this is wrong because here we have config1, the one instance of an object. But in a different component, we practically have a different variable, a different config object. And if we look into the console, if we run this code, we can see that component 1 is light. And then we can see that component 2 changes to dark. Component 2 actually receives the dark value. However, component 1, when it comes back, since it has different object, it will not register that there has been a change in the code. So this is wrong here because in our code, we expect the new setting, the set settings theme to be dark, right? So that when we read it here, when we get it back, we want both config2 and config1 to retrieve the same value. And I bet you that you encounter a website where you can change something, some color theme or number formatting, or maybe the ways the prices are shown, the currency the prices are shown in. And when you go back and when you switch between screens, your change is not following and you maybe have to refresh the page. And then you can basically tell that developers are not using a singleton principle properly, a single source of truth. Now, we could solve this using some, let's say, global variable. We could change this to global config, and instead of having something like this, instead of having a global object, we can just have this global variable here, and this will actually work just fine. It's very simple, it's easy, and it works, but it does pollute the global namespace, preventing us to have, well, multiple config objects for some different thing. And we could try using maybe dependency injection here, for example, which means that we would inject config object in every possible object, so that this component does not create the config object itself. It is being passed from the parent component, and the same for all these others. Then we will have the same object, but that will still make it easy to make a mistake and pass some wrong config instance. And we are basically relying on developers not changing anything in the code, rather than relying on the code being consistent and being more future-proof or more bulletproof and handling different scenarios. It also, when we do in each of these, there is no encapsulation, the control over the settings. It's very easy to overwrite something someplace and change the value in your object, in a sense that you can even remove this property for theme and for language and manipulate this object in a ways that was not intended. And also when we're talking about encapsulation, the encapsulation means that all of these properties and these variables are encapsulated inside this object, so you cannot reach to them the way it was intended. But also remember that even though this could be solved in many different ways, we are here learning and using design patterns as we are building robust application. We're preparing for the situation where we will have many coders working on the same code base and our application will grow and we need help with development. And in this, my ever so simple example, everything is easy. We can solve this many different ways. In real life application, things are a bit more complex, and that is why we need every tool in the toolbox. That is why we're learning Singleton. So in the skill builder module, you will get examples to practice solving this problem on your own, but you can practice now as well. So I want you that before you open the next video, you open the code from the course and think about how would you solve this, so that both component 1 and component 2 can make a new object from the config and yet still get the exact same instance of the object from memory. Let's see the theory behind the problem that Singleton solves and how it does that. In our application, we have several places where we might need to have shopping cart available. This is especially the case for some single-page applications, but you might also have multiple components at the same page at the same time, like maybe modals or hidden menus and things like that, and we want to access the shopping carts from those components, from those parts, right? We might list the items that we have in a shopping cart or maybe see the total amount we need to pay. It's a common functionality. Now, from all these places, we want to have one single cart object to work with. If we just call the new cart as usual, we will get a copy of this cart object, meaning that each cart object here will not be reflected to the original. Also, if we change something from the side menu, remove a product, it will not reflect all the other values that all the other components have. And I've seen so many applications that have these problems where you must refresh the page to get the correct information shown if you click somewhere around. which is ridiculous in 2025. What we want to achieve is that each and every component always gets one and exact one and only one cart object. Now, this could be achieved by having a cart being like a global variable, or having a factory that would create us and provide us with the correct object, or some other method where we could avoid using the new call here, the new operator. However, this can also be solved with Singleton. And what Singleton does is it allows us to call new cart and each and every time receive the original object, one and only object. This way, if we change something in one of our components anywhere in the application, say we update total amount of objects in the side menu, that is reflected by reference, because this card is just calling the original card by reference, in the main page as well, and in the orders page and in the entire application. Now, other components will not react to that change. In order to do that, we need something like, well, a React library. But that data will be updated so that if they read it again, or if they just reread or refresh that data, they will have it because they are all pointing to a single place in the memory with the single values there. And what happens here on the memory level is that if we change something in any of these car objects, because they are just reference to the one and the original object, all components will basically have the correct data, because in reality every component received the same card object, right? Even though it might look like we are creating the new card here. And in order to achieve that, we need to change a bit the way the objects are created, and we will do that in the next lesson. Let's solve our problem of having different objects and different values in different components here by using Singleton. At the end, we will have a code where both of these new config calls will always return one and only one single instance. So both of these will be the same, regardless of many times we are initiating this new object. Now, how is that possible? We are going to figure out now. Initially, we have a config class here where each component creates its own instance, right? So this config1 is not identical to this config2. And we can easily confirm this behavior. Let me just comment this here. If we were to, for example, compare config1 with config2, here we can see that comparison gives false, meaning that they are not identical objects, right? And this can lead to conflicting settings, as in our example, where one component gets one value and the other component gets some other value. And this is where Singleton will help us with this consistency. The easiest way to achieve Singleton in this scenario is to make one static property, and we can just call it instance, which will be null by default. And then this instance is going to be used to store created objects, which we are going to return later. I will show you, I will implement it first, and then we can go through the code to figure out how this works. But in essence, here in the constructor, we can just check if this instance exists. So that will be if config is not null, well, we will just return this instance. Now, this setting here could probably be moved to some method, init method. For now, I will just keep it here. But we also need to handle the case where this instance does not exist. So that's the first time we are running this constructor, right? In that case, we are just going to say config instance this. Mind you that I'm not using this because this is now a static. It means that we are not creating a new object. We don't even need to create a new object in order to manipulate this property here. But let's run this and see if it works properly now. And we can see that now this is true. And also that component 1 is light, and then the component 2 changes theme to dark. Component 2 has it to dark, and then component 1 again has it to dark. And it looks like everything works with just few lines of code. But let's see what we are doing and what we did so that we can understand how this works. Where is the hack here? Because this feels kind of like a hack, and I will come back to that later. So if I open this file side by side, it's the same file I'm opening in split view so that we can just see what is happening. So here, when we are creating a new component, the new config file in the component 1, we are setting the instance to null. That's fine. We are actually calling the constructor function here.
in the config. And what it does is it changes if this class.config, there is no object any place here. We never used new inside here. But this class instance, meaning this static instance, if it is true, it will return it. In this case, it's still null, so this will not return anything. The code will just continue, and that is fine. So the first time we create a new config, this code continues, then this setting is being set to whatever is gonna happen. Now you can see that there is this involved here, and that is basically this new object or config1 that is being now stored inside this config instance. So that means that I will just simplify it here, that this new config is now being stored inside this config instance, right? So that is in essence this static variable here. So far so good. We are getting the settings. The get settings will return this settings name. In our case, the name is theme, and in our case, the theme corresponds to this light, right? So it's very easy, just regular code so far. Now here's where the magic happens. When we call this new config from here, what is happening is that in the constructor, this is now not null. This already has the variable because this instance has been populated in the previous call. So the first time this config is being called, this instance has been populated, and this is not null, but it becomes this, which is, in our case, config1, right? That's what we pointed with yellow arrows here. Now, when we call it for the second time, this new config will not even go into the settings. It will not change anything. It will not even store this instance. It will just return config instance, which we know is basically, if we follow arrows, it is this one. So it means that when we call this new config, we are basically receiving the previous already created new config. So regardless of how many times we call new config, we are always going to return the very first instance created, this one, which then means that if in component 2 we change some settings, we are actually setting the config1 as well. And that means that both config1 is identical to config2, something that we can confirm in our browser. And we can read that here in the console, that config1 is identical, not equal value, but identical in the memory as the first one, right? So these two configs are identical in the memory. They're actually the same. If you think about physical memory, they're pointing to the same place in memory, the same space. And each time someone tries to make a new object from this class now, regardless of how many times we have this config anywhere in our application, we will always get only the first initiated value, which in this case will contain the default values. So if you change any values later, all components will be updated instantly because they are all getting to one single object with a fancy name, Singleton. Now, as I mentioned, if this seems like a hack to you, and this is not how you should use object, and suddenly there is some config instance that's not initiated, that is because this is kinda a hack. This is where the single responsibility rule is being broken by Singleton, because the class is not only caring about configuration, but it's also caring about storing this configuration and then figuring out when it should be returned, and does a bit more than just taking care of the settings that it's supposed to do. And some people even call this the anti-pattern, as in things you should not do with your whole code. But you can argue from both sides. Term hack is when we do not know what we're doing and we are figuring out our way around it. But here we are making a design decision. So we do know what we are doing and we know how this works. And we are using this only when it makes sense by decision, right? So we know all the advantages, pros and cons, and all the advantages and disadvantages. That's why we're learning design patterns. But also Singleton is used out there in the real world. So it's a smart thing to know and be familiar with. And you can make Singleton that does not break some of these important principles that we are mentioning here. You can make it a bit better and modern. And there's a lot of ways to make it, but the point is that there should be only one instance of a given object that you are allowed to use in your entire application. And it's a good thing to know of and be aware of and understand how it works. And you will practice making this yourself in the skill builder lesson, as practicing is the best way to learn hands-on. Let's look at one practical example of a problem that Singleton solved. I will now go over a few real-life examples and show you how others use this design pattern in real-life code. This way you can think where this pattern could be used in your application. First example that I found is this Aquila CMS, which is an open source all-in-one e-commerce solution. It runs on Node.js, and these designs patterns and all design patterns could be used in both backend and frontend and in all other object-oriented languages like Java and C# and similar. But this logger here that they have, actually, we can see that in the constructor, this logger is being reset to null here, and we can set that these two variables here are just a safety mechanism so that this object is being used correctly. But down here in this init method, we can see that when we call this log, there is similar code by accident that's made the same way as we did in our explanation, that if this logger is not being initiated before, so it doesn't exist, it will be initiated and then it will be called here. But if it's already been initiated, then it will just continue working here, and it will work just fine with using only these few lines under that. So this object, this logger, is a singleton. It stores its own instance. Let me try if I can find where it does that. Yeah, so here in the init, it actually initiates a new logger and puts it up into this logger variable here, meaning that no matter how many times we use this logger, we will always get one single object, because when we log here, it is already initiated only once. It will not be initiated multiple times. And second example that I have found is this tool called Medusa.js, and it's the world's most flexible e-commerce platform. I, by the way, have never used these tools, and I don't know if they're good or bad. You have to figure that one on your own. I just found this code on GitHub, and that allows me to dive deep and review them. But here in this core module, we see these property instances and also modules and loading. And here it's maybe not that obvious to see because this is a bit larger library. But here on the register module here, we can see that there is very first line, which prevents creating another module with the same key of the same type, and which then ensures that we would always get one specific instance of this module, regardless of how many times we call this register module, right? So it's only registered once. Now this could as well not be a singleton. It could be some ways of preventing duplication, but in essence it is kind of returning always the one and single object. And even if it would even throw the error here if you try to register it again. So you have to choose different alias, meaning that you will kind of get the new instance of this object. So you can see that even small and complex libraries use singleton in some different source and some different forms for different purposes, but mainly for limiting how many instances of particular object the end user and the developer can get, thus saving resources and avoiding problems in everyday operations with this code.
Let's summarize the singleton pattern to cement the knowledge. Do you remember what singleton does? We talked about situations where we might need what? One and only one object in the entire application. Well, singleton pattern is all about ensuring that a class has only one instance of an object, while providing also a global point of access to that instance. Example, if we are using JavaScript on the backend, is the connection to the database. We need one single database connection object to handle all our database queries. Otherwise, we are opening connections to the database for every interaction, which stresses database unnecessarily and can even create some weird behavior if there is a conflict. The singleton pattern solves this by ensuring that only one instance of the database connection exists, or maybe a file manipulation, or maybe API connection. And no matter how many times we try to instantiate it, how many times we try to create this object. Or we might have a configuration object that needs to be accessed by various parts of our application. So by using the singleton pattern, we ensure that all modules use, well, the same configuration file, right? Same configuration settings. Also handling some global state in our application. That could be considered a good use case for singleton, because we want single source of truth. Say in e-commerce platform, we might use a singleton for managing the shopping cart state across the entire application, across all the pages and all components, ensuring that the cart is, well, consistent no matter where the application is accessing that shopping cart. Now remember, the code implementation can be quite different. Design patterns are generally not about specific code implementation. They're a bit more about abstractions and how things should be solved in principles. And in code, they can be, of course, solved differently. There are multiple ways of making a singleton. Now, do you remember what we said the main benefits of singleton are? We talked about, let me put first the efficiency, because it helps manage resources efficiently. Since we have only one instance of a maybe resource-heavy object, like a database connection, or maybe some logger that works with files, or with some, again, HTTP connections. Now, the second thing we talked about is consistency. Singleton works the same regardless of which module we call it from, since it's only one object passed around. And we also mentioned the centralized access, because it provides a centralized point to accessing some shared resources, like configuration. But do you remember some of the challenges that follow the singleton design pattern? We talked about potential for introducing dependencies between objects. So if we are not careful, we can end up having one object and module maybe suddenly stop working unless a singleton is provided to it. So we introduce dependency. Like configuration example we mentioned, it is very easy to just summon the singleton and put it in our configuration module when we need it. But this will prevent our object working on its own, or prevent us of reusing some of components that are depending on singleton in some other places, right? Most importantly, if you ever felt that this pattern is kind of like cheating on the proper and intended use of constructor and objects and actually creating those objects, you're actually correct. Singleton pattern is often called anti-pattern, meaning that it is not good practice, because it is a common way to misuse intended functionality. Singleton breaks few good practices, mainly the single responsibility principle, as it forces class to do both managing its instance, but also giving the core functionality, which can lead to a design that is harder to maintain and harder to understand and work with. We are also storing the object inside the class itself, if you remember the implementation examples, which can be confusing if you are not well familiar with singletons. Technically as well, singleton implementation in JavaScript is a bit limited, so there are some ways you can go around it, but you are still able to duplicate and clone objects if you wish, if you want. But those are a bit edge cases. Other languages are much better at preventing object from being duplicated, because you just say it's singleton and the language will take care of it. But one more time, singleton allows us to have only one single object from its class in the entire application, thus the name singleton. And remember, watching is understanding, doing is learning. So to get most out of this course, make sure you train what we preach. So download the source code and you do the skill building lessons so that you can really learn these principles. That's why you are here, hopefully, to learn, not to be informed. So open examples from following skill build lesson and learn the singleton properly through practice.